My name is Matthias Vansenried. I'm a Python engineer. Um, I'm I'm going to talk about coding scalable tools using AWS, or at least trying to. Well, the OTT, the Online Tech Talk, are an space here at Wayprom where we can share with each other our knowledge, the knowledge that we have on features, on tools, on new frameworks, on new stuff that is could be useful for another team member. This I am recording this. I think yes, I am recording this, and this would be available on YouTube after the next week or so. Well, let's jump into the subject. The idea today is to show the strategy that I use working for one of our clients to build scalable tools using AWS infrastructure. So I'm going to talk about the AWS infra, very short comments there about the coding the tool and a solution on the results that came after coding that tool. Regarding the AWS infra, the Amazon Web Services that we use are Lambda function. Lambda function is a compute service that lets you run the code without provisioning or managing servers. Everything that I brought you here is available on the Amazon documentation. The Amazon SQS is a fully managed message queuing service that makes it easy to decouple and scale microservices, distributed system, etc. And the Amazon S3 simple storage service that allows you to save files there. The tool. Okay, the requirements were to scrape a site. The site has an API, and the API has the corresponding methods and params that allows you to perform the search on their database, on the server database, in different ways. We use part of that features. We don't use every feature available. And the scraping process is hitting an endpoint with some of the params and a specific URL for what we are searching for. The idea after receiving a response is to analyze and parse the data and give the data, save the data in according to a corresponding schema given by the client, right? And then save the file with or without results. It means that if we don't have response, we also save the data, the metadata that we call, related to what we were searching for, and if we have results, the results of using those params, or no results using those params. That's the idea. So the scrapping, we have a message producers, a message producer that saves each message on the queue, and each message has the arguments, the values that we need to query for in the URL that we are hitting, right? We receive, as I told you, we don't use the whole features from this site, and we receive three main responses or responses type. right? We have a JSON document that is type child. This when processing a child, the function hits the endpoint again to retrieve the parent data using the exact URL by parent ID. This means that if I have a document that is of type child, I need the information about the parent. So I look for information about the parent and I save the data. The other type that I receive is the type parent. The parent has multiple childs or children, so one or more child. So what we did here is to create a message for each one of the child, or for each one of the documents associated to the parent, and put back in the message queue. So when the Lambda function grabs the message, the child is a child type, and it already goes to saves the data, goes to look. It doesn't need the information about the parent, because when we save the message, we include the parent data that we need, and we just save the data because we are in the child type document, right? And the other type is a list of children. I put here is a list of child type documents, and the function, the Lambda function, creates a message for each one of them, including the child ID. So we always have this as the function or the process or the method within the function that saves the data, right? So it's like a recursive way to call. It's a way to call recursively the same Lambda function using the queue, because the Lambda function identifies which of the documents are in the response, and according to that document performs a task or another task, right? If it's a list, I will create, the function will create several messages according to each member of the list. If it's a parent, has a list of child, so we'll create a message for each one of the child. I forgot to tell you that the SQSQ has is the one that triggers the Lambda function. So the existence of a message here will trigger the execution of the Lambda function. One of the main goals here is to avoid the timeouts from the Lambda function, because if I have to process several, for example, a list of several responses of several documents, I came up with timeouts because the list was too long, or when I parsed the schema was slow, or whatever happened there makes the Lambda function to timeout, and increasing the timeout has a limit and is not a good way to set the Lambda function to do that. So by having these issues, I started to analyzing and getting the result that I built, that is always processing a child and let the child flow or process or method save the data and parse the data that we need. Also, because in the child documents, I have the 70% of the data that I need on the schema that I told you before. I have a schema to complete, and 70% of the data is in the child. 30% is in the parent when it exists. So that allows me to perform better. And the Lambda, when a Lambda function is is invoked by the SQSQ, we have we have a period where the AWS starts the runtime, starts everything related to the extension of the Lambda function, and then invokes the Lambda function. And that environment is already started for the invocation of the next Lambda function. So the time that takes to start the first time is longer than the times that takes to start the following executions or invocation of the Lambda function, right? So that allows you to perform way better by doing this on the SQSQs. This is when the scrapping process generates, as I told you, very several concurrent Lambda executions, right? And each one of them save the data in the S3 bucket. We save many files because for each child, the scrapping process saved one file. And we went from 10 to 100 to right now 110,000 messages processed without issues with this concurrent schema, right? There are there is a rate limitation that I use here because the site doesn't the servers the server side doesn't allow us to perform more than, I don't know, X amount of requests per second. So there is a rate limiter that is used in the runtime of the Lambda. That said, when Amazon starts, as I told you before, that when Amazon starts the Lambda function, starts everything related to the global functions or global variables that we use in the Lambda function, right? That global values allow me to establish the rate limiter by using that share globals between each invocation. I can rate limit. I can limit the rate of the requests that I use. So there are several hundred files generated in the bucket, and the next step, this is part of a pipeline. This scrapping process is part of a pipeline, and the next step has to process those files, perform way better with fewer bigger files. So I have, for example, 100,000 files. They are small because they have only one JSON document there, and it's too small for the next process to open each one of them and start performing the tasks that it needs. So the idea here is that we need to join all of them, because I'm working on a Lambda function that only executes a process and saves the data, and it doesn't the process didn't look for an existing file and append the data there or everything related. No. The lambda is just to scrap and to save. The lambda function is to do that. So I needed another process or function that allowed me to start concatenating the content of these files, right? So the solution on the results is apply on the S3 bucket, right? The Amazon, well, when you create a bucket, there are no, you save objects there. There are no hierarchy of sub buckets or subfolders. That structure can be inferred. I put here an example that structure of folders and subfolders can be inferred by the usage of the delimiter that they use on the object name, right? But and they call these prefixes, right? To what we know as folders and subfolders in our personal computer, for example. So knowing this, the solution were to analyze the folder, analyze each folder with the results, right? The folder as prefix, loop over the files, open each one of them, copy the content, save it on a new bigger file, and move the file to another folder or prefix that it said that allow us to know that the file was processed, right? So there are here we have when I started with a few amount of files, the Lambda function that had to solve this problem didn't have any issues because there were fewer files, very small content, and it was made within seconds or so. And the problems started when we started to scale the scraper and we received more files, right? So the solution that we think of is to make the Lambda execute different actions from steps. The steps are the ones that I mentioned here: loop over the files, open the file, copy the context, save it, read the folder. Those are the steps. So make the Lambda execute the different actions from the steps. Work with a queue and divide and conquer. That means that I identify each one of the steps. I set the Lambda to when a message triggers the Lambda, this queue works in the same way that the other. The existence of a message in the queue invokes the Lambda. So when the message gets to the Lambda function, the message has an attribute that says that identifies an action. So with the action, the Lambda knows what to do. Okay? So there is an cron event that allows the execution of this Lambda once per hour, right? That executes an action that we call the bucket action. The bucket action, what it does is to create several messages, as many messages as directories or prefixes we need to check. The prefixes, we said that they are folders and subfolders, right? So we have a folder structure that we need to go and read the directory and look for the files that we need to start reading and copy the content in order to join them in a bigger file. So each prefix operation, what it does is to read the content of a directory. There is a limitation on the functions that list the objects on the S3 that says that the function only shows 1,000 objects. nothing more, and can be paginated. So each page of the list of objects has 1,000 objects. So what we did here is to create a join message for the same Lambda, a join message with 1,000 objects enumerated in the message for the Lambda to perform that action. Is to join, is to open the file, copy the content, and create a bigger file. When the join action finishes, it generates another message that says, copy each one of these files to another folder, another prefix. The message says to copy and the list of files that I need to copy, right? And then when the copy is concluded, that method, that function, that process generates a message that says delete all these files. Copy and delete are needed because the moving function, I'm talking about Boto 3, is the SDK that we use for, is the library that we use for Python. Boto 3 that doesn't have any function that allows you to move objects between prefixes of S3, right? So I need to copy and then delete the origin. So each one of the steps executes and generate the message for the Lambda to execute the next step, right? And also the prefix step generates a message. I put the message way beyond the queue because this message has a timestamp that says you will be available within after 5 minutes. Yes, after 5 minutes. So you will be visible in the queue after 5 minutes. So when the message is visible, the Lambda is triggered, and this message that says check in the action, the thing that is searching for the files generated for each one of these join processes, right? We said that the join process that loops over 1,000 files, open them, grab the content, create another file, and save the content concatenated there in that file. So that file, the name of that file is given by the message also, right? So the name of that file will be checked by this other message by this other process, right? So the check message has the action, what I need to check, and the list of files that will be generated by this join method. And then if they exist, all of the files exist, what I do is to create another final file that has everything that is those partial copies, let's say, partial copies, showing them into one file, and copy and delete like moving the file. I prepare, I came up with this solution, I don't know why, but the idea is to use the queue to distribute the task between the several instances of the same Lambda function, right? The idea behind this is something like that. I put the message on the queue for the Lambda says I put the message on the queue for my alter ego to complete this task, something like that. this is another way to see this, because we are using different prefixes, right? So for each prefix, we have everything, every task or every messages, yes, tasks that are related to each prefix. And we can also scale this to different buckets. So the idea behind this is to concatenate the steps. I put several examples because, for example, if we have 4,000 files in the folder, right, in the prefix, I will generate 4 messages that says showing 1,000, showing 1,000, showing 1,000, showing 1,000. And those 4 will execute concurrently and will showing the content, then copy the content, then delete the files. And each one of those will be a line of processes or a concatenation of tasks related to one portion of the files that exist in that folder. And then there is the check action that says, well, I'm expecting all these files to be here. So I join them when I have them. I create a message to join them. Copy the join message will create a message to copy and to delete. The check also has retry attempts. For example, if one of the files didn't get generated, if one of the partial files didn't get generated, I check, I think 3 times, and then I explode with an error or something like that, in order to have these to cut the cycle, right? Okay, it was very difficult for me to understand what I did, and of course to explain you. I hope you have no questions, but feel free to to ask me whatever.
I always love your honesty. I'm probably the most acquainted with the work you've done, and thank you, Matthias, for putting this together. But yeah, if anyone has any questions,
I hope you like this approach. I'm open to any suggestions or whatever way to do things better, of course.
Yep, you know what I think? We've talked a lot about this.
Yes.
But yeah, this is quite an accomplishment. A lot of scraping in very little time. So yeah, thank you for this, Matthias. So if no one else has any questions.
Yes, the only thing that came to my mind, Matti, could be giving a try to step functions to do something similar. I don't know if you have seen step functions, but just as an idea. I'm not sure if it's the tool, but it has the coordination aspects that may be useful.
Yes, I knew step functions after I did this function, this Lambda code, right? I didn't study them, but Einstein gave me the idea to use step functions for another step of the pipeline that we are working with, and maybe it's a better way to perform this task, of course. But I didn't have they in my mind, you know. I didn't knew them in.
Okay, then when you implement step functions, you can give another OTT.
Ah, okay.
Yeah,
that will be right.
Hi, Matthias. I have a question. It's more related to cost and how many executions This is a process that scraps information. So basically it starts and processes an entire web page and it finishes, or is constantly running every day to scrap new information? How you handle that, and which is the cost related to all these Lambda functions that are concurrently executed?
Okay, I don't have the cost. I don't know the cost. The information that we scrap for is a URL that has the query and the params in the same URL, right? So we hit an endpoint with the params that we want to use, and we receive a response, right? So we are not navigating a site and jumping between links or something like that. We just receive the parameters that we are going to use in that URL. We build the URL, we hit the endpoint, we process the results. We generate messages when the results are parent type or list of children, that as I put you in the. But I'm not aware of the cost. The thing is that we are processing 100,000 in 1 hour and in a few minutes, something like that. I think 88,000 messages are processed per hour hitting the endpoint, right? So that's the numbers that I have. I don't have the money numbers. And the other one, processes, I have this in mind because on Tuesday we ran this process on a set of 100,000 messages, and the 100, yes, almost 100 files generated were joined together in 6 minutes and 20 seconds, something like that. And it was 6 minutes because I told you that the check message is visible after 5 minutes, right? So when is visible, after it is visible the first time, there is a second attempt within the minute or so, maybe 1 minute each minute. I check again. So at the minute number 6, let's say, the process found the files and start joining everything that remains to create the final file. So that's are the numbers that I have because of the process on Tuesday that took place on Tuesday.
Good, awesome, thanks.
Thank you, guys. If you don't have more questions, we can finalize this.
Thank you, Matthias. Thanks, everyone.
Have a nice weekend, guys.
Have a nice weekend.
Thank you. Bye-bye.
Bye.